whatever day I see you first. Is Tuesday the day I see you? I think it is. So that's the day we'll have our test. All right, and we're going to be ready. Do not fear. We will be ready. All right, number 34. I am on page 64 of my textbook, and I have another projectile motion problem. So I think we worked on this. I think that was the last one we did. So this is just more practice. A projectile is launched straight up from ground level with an initial velocity of 272 feet per second. So here is the projectile motion formula. Oh, there she is. Well, that's good, because I marked you absent. There you go. Are you all theologically put together now? Is that, huh? That's from a religion teacher.
Yeah, no, I had a meeting real quick in between the
All right, so here is our general form. I'm gonna make a decision. I'm gonna give you this, okay? I'm gonna give you the general form. Now you have to build the equation that's appropriate for this problem. So each problem is gonna have its own version of this. So for this problem, what is that going to look like for number 34? We're reading the problem. It says it's launched straight up from ground level with an initial velocity of 272 feet per second.
Is that the V?
So V sub naught is 272 feet per second. Remember, there is a T hooked to that, so don't forget the T. This is the initial height. That's 0 because, again, we are at ground level. We're starting at ground level. Oftentimes, these things are thrown off the top of the building. So if the building were 30 feet tall, then there would be a plus 30 on the end of that, right? Initial height, wherever the ball starts, how high it is, that's what goes there. It's on the ground, so that's 0. And this is the height. Do not be confused. This is function notation. It's one variable, it's the height. Think of this as in a height or a y. And this is your x. Okay? So that's the equation that we're going to use to answer these questions. All right, now A says, when will the height above the ground be 90? Now think about what's happening. Here's the ball on the ground. Here it is being thrown into the air, and here it is when it lands. That is the entire problem, right? That's the whole thing. Now, at some point along the way, we want the height to be 960. So we want to find out, looks like there's going to be two answers, right, according to my picture. We want to find out when the ball is 960 feet above the ground. So, what do we do?
You can simplify them all by 16.
Plug in 960.
Well, first I got to put the 960 in for the height, right? So I got 960 equals negative 16t squared plus 272t. Now this is a textbook problem. It's been rigged, of course. So Alexis says we can divide everything by negative 16. Now, that will not impact your answer. It makes your number smaller and easier, but you do not have to do that. So if by chance you had some random number here, like 817, don't panic. You can do the problem without dividing by negative 16. It just makes it easier to do so. How many times did that go in there? Negative 16. That's 17. All right. So again, you do not have to divide, but it makes the numbers a whole lot nicer. Now what would you suggest we do? You do have to do this. You want to get that 60 on the other side? And then we can actually factor that, 12 and 5. But if you don't see that or don't want to do that, you could use the quadratic formula. You could also complete the square, but I wouldn't recommend it because you're going to have a fraction here when you take half of this and square, but you could do that. I think I'll just factor it because that's the easiest for me anyhow. So what does that mean? When is the ball 960 feet above the ground? At 5 seconds and at 12 seconds, right? So that's the answer to the first part of the problem. Now the second part says, when will it be more than 960? So in other words, look back at your picture. More than 960 would be between 5 and 12. And since it says more than, I don't include 5 and 12. So the answer to the second part would be the interval from 5 to 12. So in other words, between here and here. Now the tricky one is the last question. When will it be less than or equal to 960? Less than or equal to. So aren't we talking about those 2 points and this and this? This is where your picture really comes in handy, because you know you have to be less than 5 and more than 12, but you can't do the infinity thing. This doesn't make any sense in this problem. On a number line, if this were a number line problem, that would make sense, but not here. Tell me about your t values. Where does t start?
0.
At 0. You can't have negative t, negative time. So your minimum is 0. And then where does t end? Right here? T ends here? We got to figure out what that is. You can do it the long way or you can do it the short way. The short way is to recognize this is a parabola. It's symmetric. So if it took me 5 seconds to get to this point, it's going to take me 5 seconds to get back down. So my t ends at 17. So given the parameters, the restrictions of the physical word problem, the fact that I have a ball going into the air coming down, I have a definite start and a definite stop. Everybody okay with that? All right, good. All right, just a couple more. What's next here? 38. Okay, well this is, yeah, this is different. This is totally different. It says, for a certain gas, P equals 400 over V. So this is some formula from a chemistry class or something. Where P is pressure and V is volume. If volume ranges between 20 and 40, can you find the values for P? Well, this isn't hard. It maybe looks hard, it maybe looks different, looks a little confusing, but it isn't. Can you figure out? They're telling me that V has to be between 20 and 40. Can you tell me what's going to happen to P then? Oh, come on, you can do this. It's easy. Yeah.
Would you do 400 divided by 20?
Yeah. We're just going to plug 20 in here. So what's 400 divided by 20? 20. So we got 200 or 20 on one end, and then we put 40 in. That's 10. So I got to turn the order around. My P's are going to range from 10 to 20. Right? If these are my V's, then these will be the corresponding P's. All right. What's next? What is that? 46. Oh, the box problem. Okay, so let's have everybody real quick take out a piece of notebook paper. Everybody have a piece of notebook paper? Just bring your old notebook paper. We're gonna rip it out, so don't make it a good piece of notebook paper. Get out your piece of notebook paper. Maybe your friend will loan you one if you don't have one. All right, everybody got a piece of paper? I'll get mine here. All right. So here's what I want you to do. I want you to construct a box. I can't see you. I need you to take the corners of your paper and rip out a square. And please, make it whatever size you want. Don't make it exactly like mine. That ruins all the fun. Whatever size square you want, but rip that same size out of each corner. So just rip a square piece out of each corner, whatever size you want, but it's got to be the same size. All four of them need to match approximately. We're not measuring, so it's no big deal. It's not perfect. Oh, I love it. Now, we all started with the same size piece of paper, so that's what I want you to keep in mind, okay? So you ripped out your corners. After you get your corners ripped out, you got these, like, little flappy things. Go ahead and fold those flaps up. And you just made a little box, right? Now here's the thing. Reese obviously jumps hurdles better than she is boxes, but here's our box. Okay. Now, Reese and I both started with exactly the same size piece of paper. Okay? Our boxes look totally different, right? Look at this one. Look at this one. Right? So here we go. Let's talk about this. If I were the nicest teacher in the world and I had this big bag of M&Ms and I walked up and down the rows and filled your box with M&Ms, wouldn't that be nice? If I did that, do you think everybody's box would hold the same number of M&Ms? No. No. They're not going to hold the same number of M&Ms. Why is that? We all started with the same piece of paper. What happened? What does it depend on? What does the size of your box depend, the shape of your box, what does that depend on?
How big you cut out the squares.
How big the corners are that you cut out, right? So you took, or in this problem, we're going to take a piece of paper that is 15 by 12, and we're going to cut these corners out, which is what you just did. And we don't know how big those corners are, but they determine the volume of the box. That's what's going to determine the volume of our box. So we folded up the flaps. There's your box. You need an expression for the volume. Now remember, the original paper, shoot, I already forgot, was it 12 by 15? The original paper, yep, it was 12 by 15. So can somebody give me an equation for the volume of this box? Think back to geometry. How do we find volume of a rectangular solid? Length times width times height, right? So what's my length? Be careful, it was 15. What is it now? 15 minus 2x, exactly, Miss Tori. What's the width of my box? It was 12. 12 minus 2x. And what's the height of my box? When I folded this up, how high did my box get? Isn't that X? So this is the equation for the volume of this box. Everybody okay with that? In this problem, I want the volume to be 125. So I want this to be 125. Now, we gotta use a calculator, because if I multiply this out, and I'm not going to, but if I did multiply it out, wouldn't it be x cubed? And you can't use the quadratic formula on an x cube. All right? So I'm gonna graph this on my calculator. Now, you got two choices when you graph it. Do you want to graph it this side, one equation, and this side the other, and look where they cross? Or do you want to move this over and look for the zeros? I don't care which way you want to do it.
Zero.
All right, and then my equation's gonna look like this. The equation I'm putting into my calculator is gonna look like this. Type it in exactly like that. Do not waste time toiling it out, because, and you're starting to make a mistake anyway. We just want to type that in. I also don't know what window you have, so you might want to zoom square if you're not getting a shape. I don't know what we have it set up for. Yeah, see mine's something down. Zoom square. Now, you didn't get a nice looking graph, but now I zoom squared. Did you get something you saw it come up quickly from the bottom? It went off the screen, it came back down, went off the screen and came back up. Is that kind of what you're seeing on your thing? Now, when we do this problem the next time, we'll be looking for the maximum volume. And that will mean we'll actually need to see, this thing goes up and turns around and comes down. We'll actually need to see that point. But for now, we want the zeros. That's what you told me you wanted to do, was find the zeros. You can see them. So the rest of the picture doesn't matter. So we're just gonna find those points. So would you take a second and find those points? Doing second, calc, 0. Taking me a minute here, but I think I got them. Is this what you got? 0.942, 3.778, and 8.780. So the question was, when is the volume 125? What size corners? So what are you going to say as your answer? When will the corners be when will the volume be 125? When the corners are 0.942, 3.778. That one's extraneous. Can somebody tell me why, even though it's an x-intercept, why is it extraneous?
Because if you if you times 8 times 2, it'd be like 16, so it's bigger than the actual.
Exactly. Think about the piece of paper that you just ripped up, guys. If it were 12 across, if it were 12 inches across, could I rip out 8 inches on this corner and 8 inches on this corner? No. In fact, there's a maximum. Remember when we did our projectile motion problem, we said you couldn't go past this certain point? What is the maximum x for this problem? If that paper's 12 across, the maximum x would be 6?
Yeah.
Right? So the problem ends at 6. It can't go past that. It starts at 0 and ends at 6. So I can only look for answers between those two numbers. All right, so these are the two where it's exactly 125. Next question is, when is it more than 125? Well, consult your picture. Isn't it more than right here? Isn't it positive or above right here? So that would be 0.942 to 3.778. And then the hard one again, it's not hard now because we talked about it, but at most 125 would be this part of the picture and this part of the picture. So everything between 0 and 0.942 or 3.778 and 6. Notice I didn't include 0 and 6. Think about the box a minute. What happens if I rip off corners size 0? Do I have a box? No, I just have a piece of paper, right? And what happens if I rip off corners size 6? Still no box because it's all gone, right? I've ripped off everything. So I'm not including those. Those are my upper and lower limits, my bounds, but I'm not including those. You okay with that? That's so exciting. So it's so exciting. We're going to do one more right now. Do the same thing on your own, but the paper is 20 by 23. So you're going to answer the exact same questions. Everything's exactly the same, but the paper is now 20 by 23. So basically, Gavin, what's that going to change in my setup? If the paper's 20 by 23. Yeah. So I'm going to have exactly the same equation, but this is going to be 20 and 23. Does that make sense to everybody? So everything's exactly the same. Oh, I put 23s in twice. Will this problem have these boundaries we were talking about before?
It won't have the same boundaries, we'll have boundaries.
It won't, you won't have the same ones. It'll have no, it will have, this one will be the same. 0 is still your lower one. What's your upper boundary this time? 10. Who said 10? Why is he?
Because 10 divided by 2.
Exactly. It's half of the smaller dimension. The smallest dimension is 20, So whatever I rip off can't be more than 10. Perfect. All right, somebody come up with some answers for me. Yep. What?
I don't know what's going on with my calculator.
What do you mean?
I can't see, like, when I'm trying to do left downs, I can't see, like, where it is.
Okay, now, when I left the window exactly the same and just hit graph. And when I did that, I saw my curve moving, but it was like going up the y-axis. Is that what yours looked like? It kind of like looked like this or something? Okay, well, that's okay. But if that bothers you, you can do the problem just like that. But if it bothers you, then go ahead and change your window so that on your x's, maybe you only go over to -1. Because you don't need all that negative stuff anyway, right? Now, it's still kind of close, isn't it? But I can definitely see it's going up there different. So go ahead and just find the point where it looks like it crosses. You don't need a perfect graph.
See, I don't see my proof that's supposed to be helping.
You can watch where it is right here. You're now up at 468, so you're way, way, way high. I'm not sure where you're trying to be. Now it's coming down, you just went over it. So the cursor may have skipped, but you can watch where you are. You are the above and below. That one's below. Are you over here? You're at 2,000. No, you're X, is that 0.2? Okay, so you are down here. You're down here right now. Is that where you want to be? Okay. I'll tell you in a second what that first one is. I gotta get there. Okay, that first one should be 0.287. Anybody get 0.287? Real close there. And then the other one. Remember, if you can't see your cursor, you know where it's at because it's giving you coordinates down here at the bottom. So even if you can't see it, that's okay, you don't need to see it. You can watch it. So the other one is at 8.713. And you guys with lines on your calculator, when you set your left bound, let's say you can't see your cursor, you're just like pressing buttons around. If you set your left bound and your line comes up over here, you're good. You're good. It doesn't matter where it is as long as it's over there. If you set your left bound though and it comes up over here, then you need to start over and move it over so it's over here. You need your left bound over here and your right bound over here if you're finding that point. These are where the volume equals 150. Right? Where would it be less than 150? Less than 150. From 0 to 0.287, or from 8.713 to 10. Remember we said 10 was going to be our upper boundary? That's where it's less than. 150. Now, where is it greater than 150? Well, that would be in between. That would be right here, right? All right, that's it. That's that up. Good work. Let's get a review workout that I gave you a while ago. And let's take a look at that. Here it is. There's a big packet of stuff. All kinds of stuff in it. Looks like this. One of the things in it, at the very end of the packet, the last couple pages, is something called Chapter P Review. Okay, so it's the next to last page, see it called Chapter P Review. So by the way, got a 3-day weekend coming up. Look at the fun you can have, right? All kinds of practice there. That's good. Right. All right, let's run through this. We'll get through as much of it as we can. Whatever we don't get through, I will ask that you take a look at before our next class, because that will be what we focus on in our next class, okay? Then our next class is gonna be all review, and it's all yours, whatever you ask me, okay? So you need to do some homework. You need to go through and dig up stuff that you don't know how to do. This homework, P7, will be due on Friday, okay? But so we can review those questions too. I don't care what we do next time, but you bring questions, all right? Here we go. Let's name the property. Let's get through as much of this as we can. Name the property. What's going on in A? So are we looking at the same problem? I am on the Precal Chapter P Review, which is, one more time, the next to last page. The next to last piece of paper. The last one is the answers. Are you ready on the right page now? Okay, what property is that right there? Additive inverse. Beautiful. Additive inverse. What's B? Commutative of addition. Jeff and Drew, math song, please. C? Reflexive. That's the reflexive property. When something equals itself. So segment BA is congruent to segment BA. That is symmetric, or reflexive. That's reflexive, right? D is symmetric, because it says if 2A equals 3B, then 3B equals 2A. You use that property all the time. If you don't like the zero on the right, you put it on the left. That's fine. And what's C? That's commutative. That's a trick one, so good for you guys that picked up on that. Sometimes when we see the parentheses, we automatically think associative, but the grouping did not change. What changed is the order. And when order changes, we are commutative of addition. That's commutative of addition. All right, is there any confusion on those? Remember in Schoology, I have an extra practice property sheet with answers. So if you're a little bit confused, you'll want to get on there and look. There won't be a ton of properties on your test, but there'll probably be a couple. All right, simplify. What do we do here? Get rid of the I in the denominator. And how do we make that happen? multiply by
3 plus 2.
3 plus 2i. We call that the conjugate. The vocabulary word, multiply top and bottom by the conjugate of the bottom. All right, Ollie, what do we do now?
So we have distribute on.
Yep, we're gonna start distributing. I call it foiling. It is distributing. That's the actual word for it, so that's good. So we're gonna distribute. So 15, 10i, 3i, and 2i squared. Remember, when you multiply 9 and I, it's I squared, just like with x's. And the bottom, what do I have to remember? I squared is -1. So this is going to become a -2, and this is going to become a +4. So now I can collect like terms. So I have a 13 plus 13i over 13. So this one actually reduces. They often don't, but this one does because all the important things here are divisible by 13. So 1 plus I is my answer.
Modeling could just be error.
Yeah, remember, this is the same as 13 over 13 plus 13i over 13. Is that okay? All right. Number 3, write the equation of the line through these 2 points. All right, you can do that. What do we have to do first? Find the what? Find the slope. And how do we find the slope?
y2 minus y1 over x2 minus.
Yep. So for my 2 points, my slope is going to be Now, where I go from here, that is not the answer.
You have to plug in one of those to the slope intercept form.
I use point slope, you can use slope intercept if you want. I'll say y minus 1 equals 1/8 x plus 2. Because if I write it this way, and the directions don't say otherwise, I can actually stop here, right? This is an answer. I don't have to do any arithmetic. This is the point slope form of the line. I don't have any directions here, so I can stop right there. If I needed the slope intercept form, if the direction stipulated right in slope intercept form, then I would have to distribute the 1/8 and add the 1. So this is exactly the same equation, but this one's in slope intercept form and this one is in point slope form. And they're both completely legit. Use either one, just follow the directions. If there aren't any directions, then pick the one you like the best. Anybody have a question about that? Okay. What? Write the equation of the line tangent to this at the point this. Okay, wait a second. What is x squared plus y squared equals 5? What is that? What? Somebody's talking? Oh, it kind of looks like a Pythagorean theorem situation. It definitely does, but that's the equation of a circle. That's a circle. Remember, circles have x squareds and y squareds? Don't just stare at me. We talked about this. What's the center of that circle? 0, because there's no numbers added or subtracted to it. What's the radius of that circle? Root 5, square root of 5. So I'm just gonna randomly draw, here's the circle, right here it is. Square root of 5 is 2 point something, so there we go. Now, on that circle, there is the point 1, 2, and there is a line tangent to the circle at that point. Your job is to write the equation of that line. Okay, now don't panic. You know how to do this. You just did it. What did you need to write the equation of your line? You needed the slope and you needed a point. You definitely have the point. Now we have to find the slope. Think about this for a second. Alexis? Think about geometry. You learned something in geometry that's pertinent. Emma, we don't need our iPad anymore. You might want to just put that down. Looks like it might be distracting you. Well, I'm going to draw this radius in. Anybody remember the relationship between the radius and the tangent? They are perpendicular at the point of tangency. Mrs. Ford, you like to know that? Yeah. You're supposed to know everything you learn. It's all in there. You just got to dig it out. So that's perpendicular. So this radius right here is perpendicular to the line I want. Can I find the slope of the radius? Okay, so the radius slope is 2 minus 0 over 1 minus 0, or 2. So what does that mean the tangent slope will be? Negative 1/2? Because perpendicular lines have opposite reciprocal slopes? So now I have my slope, and I have my point. Can I write y minus 2 equals negative 1/2 x minus 1? That is your point slope form. If you needed slope intercept form, and again, that's only going to be from the directions, kids. Whoops. That's only going to be, you're only going to know that based on the directions. If the directions don't say, feel free to stop right here. This is what you would do if you needed the slope intercept form. Okay, easy problem, but you had to remember a couple of things. All right, one more. C. Write the equation of the line perpendicular to this one and containing the point 1, 3. So it's very similar to that. Only, how am I going to find my slope this time?
You have to find the slope of the original.
And how do I find the slope of the original line?
You use the 2 over negative 4y equals negative 2 plus 1. And you divide the negative 4.
I get y by itself, in other words, right? So I'll move the 2 over, that stays negative there. Dividing everything by negative 4. I got 1/2. So the perpendicular slope will be negative 2. Everybody keeping up here? Some of you have zoned out, not good. Negative 2. And they gave me a point. So y minus 3 equals negative 2x minus 1. That's one slope, that's perfectly fine. Or y equals negative 2x plus 5. Alright, so far we're rolling through, right? Everybody's feeling good about this? Alright, number 4, here's our circle. Can you write the equation of the circle with this center and this radius? It's gonna look like this. It's gonna have this form that I'm just erasing there. That's what circles look like. So who can help me? What's that gonna look like? Julian?
It would be parentheses x, I can't remember close one.
Minus?
Minus 4, parentheses squared, and then y minus 1 squared equals 6.
Perfect. And you can remember that because it's a version of the distance formula. And if you remember in the distance formula, you subtract your x's, right? That's the same thing. It's the same exact concept. That's it, folks. That's the equation of the circle. Center at 4, 1 with a radius of root 6. Easy. Just gotta remember what it looks like. Now you're gonna do the same thing, but this time what you're told is that the diameter has endpoints at 2, negative 2, and 4, 6, and a rate, oh, that's it, that's all I know. So the midpoint of the diameter will serve as the center of the circle, right? So how do we find midpoint? Middle value.
It is, x minus x plus x divided by 2.
The average, remember, midpoint, average, because then you'll always add. When I average, I add, so 2 plus 4 divided by 2, is that 3? And negative 2 plus 6 divided by 2, that's 2, so my center is at 3, 2. Is that right? Don't let me make a mistake. So already, even if I don't know what else to do, already I can write x minus 3 squared plus y minus 2 squared, right? Already I can do that.
And you need to find the distance between the midpoint and the endpoint.
So maybe this distance right here. You could also find this one. Doesn't matter. And to find that distance, remember we do our distance formula. So 4 minus 3 squared and 6 minus 2 squared. So what is that? 1 plus, is that root 17? Which means what goes right here? 17, r squared. That number right there is always r squared. Okay, now we got a bunch of equations to solve. So I tell you what, we are not, no, I guess we'll just talk through them. All right, A. Oh my numbers are running out. Now, you do this however you want. When I do it, I'm gonna put 2 right in the middle of the number line because it's the middle number. This problem says the distance between something and 2 is bigger than 6. So here's 2. 6 this way would be 8. 6 this way would be negative 4. So these are the 2 numbers that are exactly 6 away from 2. But I need to be more than 6 away. So in other words, I need to be out here or out here. So as intervals, remembering this is negative infinity, so this interval would be negative infinity, -4, and this interval would be 8, infinity. You can do that problem however you want, just make sure that's the answer you come up with. Now B is very, very similar, but it's got an added complication. Reese, what is the added complication in problem B?
The 2 in front of
The
it.
2 in front. We don't care for that being there. So, why don't we just divide it? So now we don't have it anymore. It looks exactly like this problem now, at least pretty close to the same. So here's my number line. Right in the middle will be -1/2. Remember, it's the opposite, it's the opposite, it's the opposite. Just like when you have a circle, wouldn't the center be at -2 something? Yeah, it's the opposite, it's the opposite, it's the opposite. So -2, and then I'm gonna count back and forth 7 halves. So -1/2, which is my starting point, plus 7 halves would put me at 6 halves or 3. And -1/2 minus 7 halves would put me at -8 halves or -4. This time I want the distance to be less than 7 halves. So I'll shade in between. And my answer is the interval from -4 to 3. So this one we shaded the ends because of the greater than. This one we shaded the inside because of the less than. All right, you lively firecrackers, you, what about C? What do you want to do with problem C? Thomas, you got an idea? You absolutely could use the quadratic formula. Absolutely you could, because it's a quadratic equation. Now, when I look at this one though, I think factoring, because the numbers are so easy, but you can always use the quadratic formula. I think this one's gonna be a lot faster if I just do this. But you will get exactly the same answers as I did if you use the quadratic formula. Now the answers that you get, because this is an inequality, it's not an equals, it's an inequality. The answers that you get are gonna go on the number line. Okay? They're gonna be closed in dots. And when you have 2 dots on your number line, kids, you're gonna shade in between them or you're gonna shade outside of them. So you can either check and see where the shading is, or you can just remember that a less than means I'm gonna shade in between. Just like before. So your answer is everything from 1 to 3. What is different about problem C and problem D? Well, there's a coefficient on the x squared, but something else is different. Yep. It's an equal sign. And when it's an equal sign, that means we don't have a number line and shading. There's no greater than, less than, it's just equals. So this one, Thomas, I would definitely just do the quadratic formula, because I don't think it factors. No, I'm pretty sure it doesn't factor. And I like the quadratic formula best. got, but I did it kind of fast, so I'll just wait and see if that's what you got. That's good timing, finish the problem. Is that what you guys got? Okay, so we have completed, the paper does go over onto the back side too, so there's more going on over there. So I really need you for tomorrow to look through the rest of the problems on this review sheet, look through all the problems in the whole packet, look through all your homework problems, any problem you found anywhere that has to do with this class, and that's what we're gonna talk about tomorrow, all right? If you come in with no questions, we're starting chapter 1. We don't have time to waste, okay? So if you wanna review, you bring the questions. Everybody got it? Where are you?
On my way to get a COVID shot.
Okay, we'll see you tomorrow. Be safe. So we all understand what we need to, do for tomorrow? All right. Oh, would you make sure all of your box stuff gets put in the recycle? Let's not leave scraps of paper everywhere. So,
So many things after that.
I'm gonna hand these out to them. I'll put behind here. Please make sure you wiped off your desk and disposed of your box somewhere. Oh. Okay, remind me tomorrow.
I was not here on Friday, and he was like, I emailed him and I was like, I was there on Friday, like, is there anything I need to do? He didn't email me back, so then I go to school yesterday, and I go to class and I'm like, hey, like, Mr. Hinter, like, I emailed you, and he's like, oh, I saw your emails. I was like, okay. He was like, we didn't really do anything except for read this poem, and we've been in class since Wednesday. I was like, oh, what poem? And he's like, oh, it sounds cool, you can look at it, you'll be fine. So I'm scared.
Make sure you wipe your rest off. Make sure you have disposed of your box and your paper towels. My special box, that's my part, this is inside.
See you, Miss Morton.
Okay, I'll see you tomorrow, you ready to review?
I know, that's how I'm thinking myself.
I know.
Yes, I'm going home. She came for mad.
I know she came for this. And it was worth every minute.
Thank you. That's why.
We'll see ya. Are you sick?
No, I just have these stomach issues. I have celiac disease, so yeah, I wasn't feeling best this morning.
Yep.
I am.
All right, God bless you.
What's up, Miss Morton?
Not much, Ethan. What's up with you?
Just tired. I was out after school.
Oh, shoot, I think I forgot to turn this off. I did. So